Yeah.
So I've got this public channel, Etiwanda High AP Calculus, and that is the channel that I'm posting all the videos of these lessons. And right now they all have one view.
Is that you?
You should
Yeah.
make a video for your AP physics.
No, I am doing that too. I just haven't posted those yet. So soon there's going to be an Etiwanda High AP Physics channel as well.
It's all spaced out like that.
And it will be fun.
Yeah.
Yeah.
4 subscribers.
Hey, if anyone ever needs it, it's on the back.
I'll put a subscriber. It's not a bike.
Don't.
Nope.
I don't want subscribers. No, you can, I mean, you do whatever you want. I can't tell you what not to do, but
It's
this goes against everything I hold dear, which is my greatest possession is my anonymity.
Aren't you in front of like a couple hundred students every day?
Yeah, but still I'm anonymous. I'm a nondescript sort of person that after a while people just forget, you know? And, I mean, my goal is to get through life like as if you threw a stone into a pond and it hit the water and made no ripples whatsoever. And that's the way I'm trying to go through life, just completely have no effect on anything around me. I just go through life without Just a second.
I'm trying to take us down to space,
Oh, I see Mr. Shane. That's funny, man.
but further beyond.
I was the 5th
Trying to
subscriber.
push that thing.
This silly guy.
I'll be like,
Okay.
aerospace.
Yeah, there he is. I think the camera makes me look fatter. Okay, quotient roll.
Look cute again.
Alrighty. Again, I'm not going to prove it to you. All I'm going to prove to you is the product rule because that's all it requires. I don't know. Quotient rule, here comes. If you've got the derivative with respect to x of two quantities, let's say it's, I don't know, let's call it n of x over d of x. Do you mind if I call them that, where n means numerator and d means denominator? Then the quotient rule is going to be a fraction, and does anyone remember what this first term of that fraction is? Yeah, Andrew.
It's the derivative of the bottom one times the top one.
How many people say it's the derivative of the bottom times the top? You're wrong! Wrong. Wrong.
Is it flipped? Is it the other way or is it?
It's the other way, yeah. And did anyone memorize this low D high, high D low over low low? Did anyone learn that? No. Good, don't. I don't. This doesn't require a mnemonic device. Just, it's the derivative of the top times the bottom. That's the first term. So it's going to be the derivative with respect to x of the numerator, derivative of the top times the bottom, minus the top times the derivative of the bottom. You guys okay with that? It's the derivative of the bottom that goes after the minus sign. And then on the bottom is the bottom squared. So the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And you can make sure that you don't get the numerator terms mixed up by just treating it like it was the product rule, right? That is, if I have, you know, f of x equaling n of x over d of x, numerator over denominator, are you guys okay that I can rewrite this as the numerator times the denominator to the -1 power? Are you okay that this is the same as that? So when I apply product rule, when I get f prime of x, it's going to be the derivative of the derivative of the first guy times the second guy, okay, plus the first guy times the derivative of the second guy, and or maybe instead of n prime, let me just keep using that notation there. The derivative of the top guy times the bottom guy to the -1 power, plus the top guy times the derivative of the bottom guy. And are you okay that when I do, oh, I guess I should be showing you this later. Oh well, my bad. But you do general power rule, and it'll be -1 times this guy to the -2 power times the derivative of this guy. So I don't know if I'm really convincing you of anything. The only thing I want you to see right now, because I have to teach you something called the general power rule. So anyway, thank you, camera. This is all just a big waste. But at least I want to, I mean, don't stop the camera or anything. But I just want to let you guys know that when you do product rule on this quotient, you end up sprouting a -1 because of the power rule. And so it's the denominator that's going to have the -1 in front of it when you take a derivative. You know, this minus sign here comes from this, comes from taking the derivative of the denominator to the -1 power. So it's the denominator, the derivative of the denominator has the minus in front of it because of that phenomenon. I'm hoping that helps you to remember it, because I gotta confess that, you know, my son in Claremont High, he's learning this mnemonic low, he's learning low D high minus high D low over low low. And I just don't like that. I mean, number one, because usually when I use high and low, I say high D ho, and so I'm gonna get confused and think it's high D low minus low D high, when it's really low D high minus, well, forget all that. Just remember that the derivative of the denominator is the guy who gets the minus sign because of this. All right, well anyway, hey, let's do a problem, okay? How about the derivative with respect to x of x squared plus 5x minus 2 over 3x plus 5, okay? Let's say I want that derivative, then I'm gonna take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And there it is, there's your derivative. Sometimes I'm going to want you to simplify it, sometimes I'm not. Right now I don't feel like it, so I'm not. But if you had to, you would, you know, multiply it out and combine like terms.
Mm-hmm.
But I don't feel like it. Okay, so you guys okay with quotient rule? Where's my quotient rule? Is there a cool problem I'm going to give you? Yeah, let's give you this cool problem. Try this. And I'll talk more about the proof of the quotient rule later when we learn about something called the general power rule, which you guys haven't learned yet, so I couldn't really show you that in earnest. But what if f of x equals 3 minus... Okay, I'd like everyone to please find the f prime now. Now that's good enough. Before we go any farther, I hope everyone's turning radical x into x to the 1/2 power. You're either doing it on your paper or in your head, but that's the only way to take the derivative of radical x is to turn it into x to the 1/2 power. Alrighty, let's go for it. The derivative of the top, which is -1/2 x to the -1/2 power, times the bottom, minus the top, times the derivative of the bottom, all over the bottom squared, Okay. How many people got that answer? Yay, that's good. And if I asked you to simplify it, you would, but I'm not, so you don't have to. Although, I don't know, I might simplify into something really cool, but I don't care. All right, well, hey, that's the quotient rule. Let's go ahead and do problems like number 23 and 24. Okay. There's a problem that our textbook loves that I actually love. So I need to make sure you can do them. They'll give you a problem like this. But I want to give you a problem that's not precisely what's in the book. Just a second. Yeah, cool. Okay, yeah. So let's say I can't do that. I can't do that. I'm changing horses in the middle of the screen.
It's the most fun thing to do.
For f of x equals u over v, where u and v are both functions of x. There are things with x's in them, like maybe your u is 3 minus rad x and your v is x plus 2, but who knows what they actually are, okay? For f of x equaling u over v, find f prime of 0 given that u of 0 equals 3, u prime of 0 equals 4, v of 0 equals -1, and v prime of 0 equals 2. Okay? I should put semicolons in there. You guys okay with that? U of 0 equals 3, u prime of 0 equals 4, v of 0 equals -1, v prime of 0 equals 2. They're essentially wanting you to practice doing quotient rule in this case. So I'm going to first get an expression for f prime of x, and because that's a quotient, it'll be the derivative of the top times the bottom minus the top times the derivative of the bottom. So this is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. And now I'm going to plug in those numbers, because they specifically want f prime of 0. So to get f prime of 0, I'm going to need u prime of 0 times v of 0 minus u of 0 times v prime of 0, all over v of 0. I'm just plugging 0 into those functions. And although I don't know what u and v are, I do know the values at 0, so I do get to plug those in. So here it comes. U prime of 0 is 4. V of 0 is -1. U of 0 is 3. V prime of 0 is 2. And v of 0 squared. V of 0 is -1 squared. And so this ends up being -4 minus 6 is -10 over 1, so I get -10. Yay. Does this make sense to you guys? Okay, then I'd like you to do one on your own. And the one you're going to do is a product rule problem. Here, using those same values, 3, 4, -1, and 2, f of x equals u times v. Find f prime of 0. Please do this now. You know, one thing I'm really proud of is on YouTube, my whiteboard is going to be so clean and white. I think that's really important. People take me more seriously as a teacher because I have a clean whiteboard. I would.
If you had a chalkboard, would you keep that one really clean too?
Yes, in fact, when I had a chalkboard, I kept it really clean. Yeah. I wonder if it's something with me, it's some sort of OCD thing with me. No, I think it's just because I want to be an excellent teacher. Yeah. No, yeah, I had like one type of eraser for erasing the chalk and then a different one that you could erase the board and make it look all clean, you know? A different, like a leather sort of eraser.
Oh, that's cool.
Very cool. Those were the days. Chalk on my hands. Alrighty, hey, let's go for it. Did you guys get an expression for f prime of x being the derivative of the first times the second plus the first times the derivative of the second? Did you guys do that? Yeah. Yay. And then now we're going to get f prime of 0. And so u prime of 0 is 4. V of 0 is -1. U of 0 is 3. And v prime is 2. So you end up with 2. How many people got 2 as their answer? Okay, then problems 23 and 24 shouldn't be a problem for you. Good. All right, then hey, let's talk about y double prime. Just as there's a million names for y double prime, for y prime, or f prime of x, or dy dx, there's also a bunch of names for y double prime, and I just need to expose you to them. So here they come, all the names for y double prime. Where is it? I don't want to forget any of them. So, oh shoot. Alrighty, well here we go, I'll just do this. Names for y double prime, the second derivative. Okay, so if you have a function y, then y double prime is going to be the second derivative. Alrighty? There's another way to express the second derivative, and it's to call it f double prime of x. And again, that means they want you to take the derivative, get that answer, and then take the derivative of that. And I think that's pretty self-explanatory. Okay? There's a third way to write the second derivative. That is, you can say that this is the derivative with respect to x of y prime, where you're using d over dx as an operator that says whatever comes after the d over dx, go ahead and take the derivative of it. Alrighty? Or you can express it like this, the derivative with respect to x of dy over dx. Again, you're going to get dy dx, which is the first derivative, and then you'll take the derivative of that. So take the derivative of the first derivative. And then you get this really weird, freaky thing, which I have to confess, I'm sure I should Google it, but I just don't know where this came from or why or what sort of significance it has. But mathematicians decided, well, you know, I don't want to write this, but this looks like d times dy, and d times dy would be like the d is squared. So they go, okay, well, that's d squared y. And then the bottom, dx times dx is dx squared. But we're not even going to put parentheses around the dx. We'll write it like that. So this comes from this, but it makes no sense at all, except now this has become the symbol for the second derivative. So, and books seem to prefer this. So when they ask for the second derivative, they'll say d squared y over dx squared. And I just don't want you to look for any mathematical meaning out of it. It's just a symbol that means the second derivative, a symbol derived from this, even though it doesn't make any sense at all. Okay? And so then what happens is, let's say you want to take the derivative of the second derivative. That is, let's say you want to get the third derivative. Then they call the third derivative d cubed y over dx cubed. Again, even though it has no meaning at all. It's just a symbol for the third derivative, and so on. You know. So if someone says, find me the 10th derivative, well, they can either do this, you know, the 10th derivative with respect to x. No one's going to put 10 little hash marks. You know, because the third derivative 3 hash marks is workable, right? I mean, I can have y triple prime or f triple prime, but by the time you get to the 10th derivative, it's no good. So they end up doing that, or more conveniently, they'll do this. So I just don't want you to be confused when you encounter these symbols that mean these things, So you guys are okay with that? All right, it's just the terminology. Last, a proof of the product rule. Here it comes. Everything I taught you yesterday and today can be proven using the definition of the derivative. I'm going to show you the product rule. Okay. Proof of the product rule using the definition of the derivative. So I want the derivative with respect to x of f of x times g of x. Alrighty. Well, I'm going to do the limit definition. So this will be the limit as h approaches 0 of f of x plus h. Just one second. Times g of x plus h minus f of x times g of x all over h. Are you okay that all the definition of the derivative does is you plug in x plus h, then you plug in x and subtract them and divide by h, and now we get to the slope of the secant. And then, as h approaches 0, I get the slope of the tangent. Are you guys okay with that so far? Okay, thank you, Chris. Thank you for nodding your head. Next, I'm going to do this clever trick. I'm going to sprout a term in the middle. I got f of x plus h times g of x plus h minus f of x plus h times g of x plus f of x plus h times g of x minus f of x g of x. And you don't have to write this down. Well, did I tell that to you guys? You don't have to write this down. Just watch and enjoy. I mean, I'm not going to ask you to know this or anything. I just want you to see that the stuff we're learning isn't magic, that it actually comes from somewhere. So I just sprouted these two terms, but I didn't change the value of the numerator because this is the negative version of that term and this is the positive version. They add to 0. So I have to change the value of the numerator. But now here's the interesting thing. I'm going to factor out f of x plus h from the first two terms of the numerator. So I got the limit as h approaches 0 with f of x plus h times g of x plus h minus g of x. Alrighty. And then I'm going to factor g of x from this guy. So I got f of x plus h minus f of x. All of this over h. Okay. I just factored these two terms. Factored the f of x plus h out from these two terms. Factored the g of x from these two terms. And the next thing I'm going to do, and I'm not going to rewrite it, I'm going to say, hey, if I've got a sum in the numerator and a single term in the denominator, like if I have 1 plus 2 over 5, you guys are okay that this is 1/5 plus 2/5, right? That you can split up the numerator?
Mm-hmm.
So I'm going to do the same thing here. I'm going to split up the numerator and turn this into this guy and this guy with this plus here and then this limit. Okay, that is all I did was split up the numerator. Do you believe that I can do that? That's okay. Oops, sorry. And so now look at this. This term here. What's that? The limit as h approaches 0 of g of x plus h minus g of x over h. What's that equal to?
G prime.
G prime of x, yeah. So I'm getting the limit as h approaches 0 of f of x plus h times g prime of x. Okay? Look at this. What's this guy here equal to?
F prime of x.
F prime of x. So I got the limit as h approaches 0 of g of x times f prime of x. Okay? Well, here, if h is approaching 0, f of x plus h gets closer and closer to f of x. So I've got f of x times g prime of x. And then here, the limit is h approaches 0. Well, there's no h's there. So I've got g of x times f prime of x. Do you guys see that that's the quotient rule? I mean, the power of the product rule. That's it. There it is. That's the proof of the product rule. All you had to do is cleverly sprout these two terms and factor and split the numerator of the fraction, and you end up with the product rule, that the derivative of two things multiplied together is the first times the derivative of the second plus the second times the derivative of the first. All right. Well, anyway, that's the proof of the product rule. Any questions or issues? Pretty nifty. Yeah. Okay. Well, hey, guess what? I'm done. So you got 15 minutes left. If you happen to have your book with you, what should I do? Yes.
Oh, my God.
No. Yeah, this is weird.